let us take a problem of finding collapsed load in the case of a fixed beam subjected to two concentrated loads. So we have to find the WU. So WU is the unknown, and he has given that the value of MP is constant throughout. So there is no change in the cross-sectional area or moment of inertia or MP value. So here, as I already told the earlier videos, in the case of a fixed beam, redundancy will be 2 and the number of plastic hinges required to form collapse mechanism is the 2 plus 1 or plus 1, that is 3. So if minimum 3 plastic hinges are formed, so then this beam will attain a collapse mechanism, that is a beam mechanism. Now if you observe the diagram, plastic hinges will form at 4 points at A and B because they are subjected to hogging bending moment, and also under the loads C and D. So totally there is a possibility of formation of plastic hinges at 4 points. But to attain mechanism, only 3 plastic hinges are required to attain the mechanism. So now there will be 2 cases here. In the first case, let us take that the plastic hinges will develop at A, B and at C. Then the second case, we take that the plastic hinges will form at A, B and D. So under the load. So now, first case I will take up plastic hinges forming at the support, that is A, B, and under that 1.25 W load, that is at C. Now if you draw the mechanism for that, so this is the B mechanism, here it will be C, here it will be D. So there is a development of 3 plastic hinges like this. Now here, when you take up the plastic hinges forming at A, B and at C, this is A, this is B, this is C, you have 1.25 WU. I will take it as U because it is under collapse condition, and there is one more load here, that is W at D. This is at D. Now that means when you are writing that equation, internal work done is equal to external work done, you have to take these 2 deflections. I will call them delta 1, this as delta 2. Because deflections under both the loads we have to consider. Now the value of MP here is MP only. Here also it is MP. Here also it is MP because MP is constant he has given. And coming to the slopes or rotations, here it is theta. Here also it is theta. Here it is theta 1. Here it is theta 1. So if we extend this becomes theta. So total rotation here at C will be theta plus theta 1. Now if I write that equation, internal work done is equal to external work done. Internal work done is due to the formation of plastic hinges. External work done is due to the loads. So internal work done is given by the product of MP and the corresponding rotation. External work done is given by the load, the product of load and the corresponding displacement. Now here internal work done expression is MP into theta at A plus at C it is MP into theta plus theta 1. Total rotation is theta 1, theta plus theta 1, and at B it is MP into theta 1. This is the total internal work done. This should be equal to external work done is the load multiplied by the corresponding displacement or the deflection. So 1.25 times WU multiplied by delta 1 plus WU load here is WU into delta 2. Now we have to get the relationship between delta and theta. So for that, as usual, earlier whatever we have done, consider this triangle. If you consider this triangle, since theta is very small, I write here, theta can be equated to tan theta, and from this triangle, tan theta is delta 1 divided by this distance is 1.2 meter, this is 3.2 meter, and this is 1.5 meter. That is given in the problem. So your tan theta will be delta 1 divided by 1.2, or I can write delta 1 as 1.2 times theta. This is the relation. Similarly, if I want to write for delta 2 in this triangle, I have to take this triangle. Theta 1 is very small, it can be equated to tan theta 1. Tan theta 1 from this triangle is delta 2 divided by 1.5. So therefore, delta 2 is equal to 1.5 into theta 1. So we can write like this. Now I need the relationship between theta and theta 1 also. So if you consider this triangle, that is this triangle and this triangle, only two triangles. So you can observe here that from this triangle you have delta 1 is equal to what we got 1.2 times theta, and from this triangle we got delta 2 is equal to 1.5 times theta 1. Now I have to take these two triangles. Okay, if I take these two triangles, you can get a relationship between theta and theta 1, or this triangle and this triangle. Okay, what I will do here is, now to get the relationship between theta and theta 1, let me consider this triangle. If I consider this triangle, you have delta 1 is equal to same thing, 1.2 times theta. We got here whatever we have got here. If I take this triangle, bigger triangle, so if I take tan theta 1 will be delta 1 divided by this distance. This distance is 3.3 plus 1.2, that is 4.8. So I can write that. So tan theta 1 is equal to theta 1, that is equal to delta 1 divided by 4.8. Or I can write delta 1 as 4.8 times theta 1. So now you can compare these two and get the relationship between theta and theta 1. So if you observe this, so what happens here is, I can take this as 1.2 theta is equal to 4.8 theta 1. Or in other words, I can write theta 1 as 1.2 divided by 4.8, that is 0.25 times theta. Okay. So this is what we will get the relationship between theta 1 and theta. Now, in this equation, whatever we have got in this equation, you substitute for theta 1 as 0.25 theta, delta 1 as 1.2 theta, and delta 2 as 1.5 theta 1, and for theta 1 we have to put this. So let us substitute now. So this here I can take MP common. So substituting in 1, I can take MP common here. So MP into theta plus theta 2 theta plus 2 theta 1 will be equal to 1.25 times WU into delta 1. Delta 1 is 1.2 times theta. Do it carefully. Plus WU into delta 2. Delta 2 is 1.5 times theta 1. 1.5 times theta 1. Okay. This is how we can get. Now for theta 1, you have to put 0.25 theta. So this becomes 2MP into theta plus 0.25 theta is equal to 1.25 into 1.2. So WU I can take outside. W into 1.25 into 1.2. Let me calculate it. 1.25 into 1.2 will be 1.5. 1.5 times theta plus here it becomes 1.5 into theta 1 is once again 0.25 times theta. So you get this. Now this becomes 1.25 into 2. It becomes 2.5 mv theta is equal to WU into this is 1.5 into 0.25. So it becomes 0.375 plus 1.875 theta. So you can cancel this theta. So WU you take it as this divided by this, that is 2.5 divided by 1.875. So which is 1.333 MV. This is what you get for the first case. So this is the collapse load when the plastic hinges form at A, B and C for the first case. Now in the second case also we have to find out the WU, and afterwards whichever is the lesser value that we have to take as the final answer. So in the second case now, let's go for the second case. In the second case, plastic hinges forming at A, B and D. Let us assume that the third plastic hinge will form at D now. Now the corresponding mechanism now, I will write the mechanism. Now the plastic hinge is formed at D here. So this becomes MP. This is D. At B also is a plastic hinge. At A also is a plastic hinge. So plastic hinges are denoted by dots. So like this. And at C you don't have plastic hinge, but deflection will be there. So here there is a load of 1.25 WU, and here there is a load of WU. So here also this is delta 2, this is delta 1. So deflection will be there under both the loads. And as usual, this is for the distances I will write 1.2 meters, 3.3 meters, 1.5 meters. Totally it is 6 meters. I will take this as theta, this as theta 1. As usual, this will be theta. Here this will be theta 1, this will be theta. Total rotation here is theta plus theta 1. Okay. So here also we need to find the relationship between delta 1 and delta 2 as well as theta and theta 1. So let me write the relation now. If you take this triangle, so that is this is C. This triangle, if I take theta nearly equal to tan theta, which is equal to delta 1 by 1.2. So therefore, delta 1 is equal to 1.2 times theta. This is the relation. Next, second relation, this triangle I will take theta 1 nearly equal to tan theta 1, because theta 1 is very small. Delta 2 divided by 1.5. Therefore, delta 2 is equal to 1.5 times theta 1 in the second relation. Now I am the relationship between theta and theta 1 also. For that I have to consider this triangle and this bigger triangle, just like what we did here. So let me take this triangle now, this bigger triangle. So if I want to find this delta 2, by using delta 2 we can get the relation now. So I will take this bigger triangle and this triangle, so that delta 2 is common. So if I take this triangle, so theta nearly equal to tan theta, which is equal to, in another way we can write this as, in this bigger triangle, tan theta is delta 2 divided by 4.5. 4.5. So therefore delta 2 can be written as 4.5 theta. Now you see here, delta 2 is equal to 4.5 theta as well as delta 2 is equal to 1.5 theta 1. So therefore by equating these two, what we can write here is therefore 1.5 times theta 1, which is delta 2, is equal to 4.5 theta. And in other words, delta 1 is equal, theta 1 is equal to, I can write theta 1 as 4.5 divided by 1.5 is equal to 3 theta 1. And this is the relation. So just like what we get 4 relations here also we got 4 relations. Now we will write the internal work done is equal to external work done equation, and we find the WU value, and then later on we have to compare that value with this, whichever is the least value, that is the value of WU. Now let me write that internal work done is equal to external work done for the second case. So internal work done is MP into rotation, external work done is load into deflection. So I will write here now, internal work done is equal to external work done. So this is due to formation of plastic hinge, this is due to external loads. So internal work done, here MP into theta, here MP into theta plus theta 1, here MP into theta 1. So there are 3 plastic hinges. At each plastic hinge you have the rotations plus MP into theta 1. This is the internal work done. This should be equal to external work done is 1.25 WU into delta 1 plus WU into delta 2. Yes. Now let us substitute the things using those relations. Here this becomes 2MP into theta plus theta 1 as in the earlier case. Here I will take W as common. It becomes 1.25 delta 1. Delta 1 is 1.2 times theta plus. Here delta 2 will be there. For delta 2 I can write it as 4.5 theta. Okay. So everything will be in terms of theta, so that we can cancel the theta. So here also for theta 1, you have to put it as 3 times theta. Theta 1 is 3 times theta. Therefore 3 theta plus theta 4 theta 8 whole to 8. 8 MP theta is equal to WU into, this is 1.25 into 1.2, which is 1.5 plus 4.5, that is 6 theta. See, this 6 theta. Now we can cancel this theta. So WU will be equal to 8MP divided by 6. 8MP divided by 6, which is 8 by 6, that is 4 divided by 3, which is equal to 1.33 volts. 333. That means we got the same value for both the cases. Please notice that we got the same value for both the cases. Suppose if you get different values, the least value, lower value, minimum value is taken as the WU. So I will write here the least of the above WU values is taken as the final collapse U. Of course, in this case, we are getting both the values equal. Therefore, WU is equal to 1.3 times E. So this is the final answer. So by knowing the fully plastic moment carrying capacity of the section, we can find out the value of collapse zone. I will give an example here. So if you take MP as 100 kilonewton meter, let us say, what is the corresponding W value you can have. That means at what load the beam will transform to a mechanism. Mechanism means failure, collapse. So till that load you can apply the load. Till that stage is reached, you can apply the load. So I will give an example. If you have MP is equal to 100 kilonewton meter, this is an example. What is the value of WU? So WU will be 1.333 into 100, which is 133.3 kilonewton. So up to this you can apply the load. So here this is 1.25 times that value, and here it is 123.3. That means the collapse will be, it will be like this. The load at collapse will be, this is 1.25 times 133.3, and this is 133 kilonewton. So this is A, C, D, corresponding distances are there. So this is the point of collapse. So this is how we can solve, or we can find the value of collapse load. If two concentrated loads are given, if it is a fixed beam, then naturally 3 plastic hinges will be there, 2 plus 1 plus 8 times is 2 in fixed beam. Since there is a possibility of formation of 4 plastic hinges, only 3 plastic hinges are enough to have the mechanism. So therefore, we have to consider 2 cases here. One at these 2 supports and the other one under the load. So calculate WU using kinematic method, determine work done is equal to external work done. Then get the value of WU in both the cases. Take the least value as the final collapse load value. Suppose if you get equal values in both the cases, then you take that value itself as the collapse load.